Okay, so we're going to start chapter 5 today with 5.1. Like I've mentioned a couple times, the 5 and the 6, both chapters, they're probably the hardest things that we're going to cover all semester. So just take it slow. 5.1 starts off, this is a little bit of a review. We're just going to make it a little bit juicier with proving identities. So first off, I just want to recall like all of this stuff we've actually already learned. So the reciprocal identities, which are like your sines, cosines, tangents, secant, cosecant, cotangent relationships. So we can say sine of theta is the same as 1 over the cosecant. And then likewise, cosecant is 1 over the sine. Cosine is 1 over the sine of theta. Oh, I'm sorry, 1 over the secant of theta. And then secant of theta is equal to 1 over the cosine. Oh, yeah, okay. I thought I made the same mistake twice. And then tangent of theta is 1 over the cotangent. And then cotangent of theta is 1 over the tangent. Those are reciprocal identities. We've worked with these like over and over and over again. The ratio identities are your tangent identities. So what is tangent equal to? Tangent's equal to sine over cosine. And cotangent is equal to cosine over sine. All right, and then the last one, the Pythagorean identities, we get 3 of them. We get the big one, sine squared plus cosine squared is equal to 1. And then we get the other 2. We derived the other 2 way back in the beginning of the semester. So if you want to see how it's done again, go back in those notes. I believe it was unit 1. We talk about how the other 2, we get the other 2 by dividing by sine squared and cosine squared. So I'm going to get 1 plus cotangent squared is equal to cosecant squared. And I get that when I divide everything by sine squared. And then the other one I get is 1 plus tangent squared is equal to secant squared. Okay, these 2 come from that one. We've done all this before. So I've got 2 quick proof questions to go through. These are not meant to be challenging. They're just kind of meant to like warm us up for the more challenging ones. These are stuff that kind of like I would have asked you to do previously in this semester. So prove sine of theta, cotangent of theta is equal to cosine of theta. We've done these problems before, and I've said, listen, do not cross this equal sign. Work on one side only. It's typically the left, and we want to make sure that the left side at the very end is the same as the right side. So one strategy we did was change everything to sines and cosines, and that's a good place to start here. So I'm going to change cotangent to cosine over sine. So I have sine times cosine over sine. Exciting thing is that the sines cancel out. You have 1 on top, 1 on the bottom. We have cosine is equal to cosine. Done. I want the left side to look like the right side. So don't like write this part and then say all done. Make sure that the last line is the exact same. Okay, now this one, you have cotangent of x plus 1 is equal to cosine of x times cosecant of x plus secant of x. All right, there's a lot of stuff here. We could probably work on the left. I think it would take us longer just looking at this a little objectively. It actually might be quicker to work on the right. So let's do the right side. So I'm going to change everything on the right to sines and cosines. So cosecant is 1 over the sine of x. And secant of x is 1 over the cosine of x. Oh yeah, this is going to be a lot easier. All right, and so my left side, we didn't touch the left side. All right. And I think you guys saw a problem like this before in this class. It's kind of tempting to add these fractions. Don't. You can do it. You're going to have to take like a couple more steps to get to the finish line. So just leave them. And what I'm going to do is I'm going to distribute this cosine of x through this fraction. You can add them, all right? Don't think that you can't do it. You can do it. It will just take you longer to get to the end point. All right. Now, cosine over sine is cotangent, and cosine over itself is 1. Look at that. Perfect. 3 steps. With the fractions, it would probably take you 5 if you added them, theoretically. But you would still come to the same conclusion. And once again, you could probably have done the left side. I would have changed cotangent to cosine over sine, added these fractions, and then you would have factored out a cosine. I don't know. I think working on this right side was a little bit more intuitive.